Hello everyone. In this lecture, we will be covering the basics of potentiometer, and in the basics of potentiometer, first we will see what is the purpose of potentiometer, then what are the different types of potentiometer, then what is the basic construction of different types of potentiometer, then we will see how does it work, what is the working principle, then we will see what are the basic characteristics on which you define the potentiometer. Matlab, why do you want to buy the potentiometer? It depends upon the characteristics that you'll get from that device. Okay, so what is that characteristics that you'll get from that potentiometer? Then what are its advantages and what are its disadvantages? Rather than saying disadvantage, in measurement we try to say its limitation, because there is nothing as such as disadvantage. Because if there will be some disadvantage, we won't use that potentiometer, because it might happen that the disadvantage might supersede the advantage. So always we use the word limitation, that is more preferred. Matlab, in these conditions we can't use this instruments. Okay, so when we consider the word potentiometer is actually a resistance based, it is a resistance based displacement measurement system. Yeah, displacement measuring instrument. Okay, it is a resistance based displacement measuring instrument. Okay, now there, if you have come from 12th standard, and even if you have studied physics, okay, especially the physics which was related to electronics, you might have heard the word potentiometer. You might have even heard this word potentiometer even in your electronics lab. If not, if it is not there, then it's not an issue, but you must have heard this lab word potentiometer. So potentiometer is one of the fundamental instruments. Matlab, it is one of the fundamental instruments to measure various things in electronic setup. Okay, so what we are basically going to do, we are going to use it only to measure displacement, because our purpose is to measure the displacement. Matlab, it will act as a transducer which will measure the displacement in terms of some kind of a voltage. Okay, because it is using resistance, and we already know resistance is proportional to voltage. Okay, so what we will be doing in this lecture is we will cover how does a displacement type potentiometer work. Okay, and what are its basic types, what is the construction, what is the working principle, what are its characteristics for which you should buy the potentiometer, then what are its advantages and limitation. I think I have already covered all the things in precise detail for you to understand and for you to proceed. Okay, so what I'll do is I'll go to the next slide. Okay, I'll just show you this slide. Yeah, just look at the basic purpose. I've already mentioned the basic purpose. What are the few basic purposes of potentiometer? First, in relevance to all the electronic instruments that I am saying, it is used to compare two EMFs. Matlab, if you want to compare the battery voltages, EMF is nothing but a voltage, but when it is given by the battery, it is called as EMF. When you measure it around a wire, it is called as voltage. Okay, so it is basically used to compare battery voltages. One of the purpose. Okay. Second, to find internal resistance of a battery. Now we know that battery is nothing but a system of wires. Okay, it will have some wires in it. So if it is having some wires, it will also have the internal resistance. Those wire will also have the internal resistance. So suppose you want to find, suppose you have designed a potentiometer for a resistance R of the wire, because potentiometer is nothing but resistive type. I hope you're getting, I've already explained. Potentiometer is nothing but resistive type, whether it is used for measuring displacement or for some other entity. It is always used for measuring, it is also always used in relevance to resistive type. Okay, when we are saying potentiometer, so suppose the system or the wire that we were using, it is having some resistance R, but this battery, okay, this battery is also having some internal resistance R. Okay, so what might have happened, that we have designed the potentiometer only to measure only with respect to R. Okay, but since we are getting some internal R also, so we should be able to find the internal R, so that we can compensate. When we go for analytical problem solution, we can compensate that thing. So to compensate analytically, what we, or even experimentally, if we want to compensate that thing, this internal resistance, so that my instrument, you can say the range for which my instrument is designed is properly working and it is properly calibrated. So for that reason, we even need to find the internal resistance of the battery. Okay, it is also used to find the unknown EMF. Suppose there are two battery, one is having an EMF 1 E1 and another is having an EMF E2. Matlab, you can say it as the voltage also. Okay, voltage for battery 1 is suppose karo E1 and voltage for battery 2 is E2. So suppose you know the value of E1 and you know, suppose you know the value, this value is known to you, okay, and you want to find the unknown value. You don't know what is the value of the second battery, okay, so you can even find it by using the potentiometer. It is also used to find the unknown EMF, okay. So I have already told you three basic purpose of potentiometer. One of the basic purpose that I have told you is it is used to compare two EMFs. Matlab, if I want to compare E1 by E2, so I can compare it, okay, directly I can compare it, the battery EMFs. It is used to find the internal resistance of the battery. It is also used to find, suppose E2 is unknown, we can even find E2, okay. So these are the basic things for which we can use the potentiometer. Now the main application for which your subject is designed is, it is used as a transducer to find the displacement, okay. Now this type of transducers of potentiometer are called as resistive pot. What do we call it as? Resistive pot, because it is based on the principle of Ohm's law, because it will use resistance, okay, it will use some kind of resistance to convert it into displacement. We already know what is the transducer. It converts one form of signal to another form of signal. So suppose there is a displacement, suppose there is a system which is moving, okay, and when this system is moving from this position to this position, it is covering some displacement. You can see this will be the displacement, okay. So this displacement will get calibrated into resistance, okay. That's why it is called as resistive type potentiometer. And okay, so this type, the type that we are going to study is, it is said as a transducer which is used to find displacement. It is also called as resistive potentiometer because it converts displacement into resistance, and it is also called as voltage divider. There is another name for potentiometer, resistive potentiometer. It is also called as voltage divider. Okay, I'll just explain you voltage divider when we get into the details of this topic. Okay, I'm just fast forwarding it right now. If anyone is having any doubt, they can put it in the chat. If you are having any doubt, just let me know as quick as possible in the chat so that we can cover this topic precisely. Any doubt till now? Just put it in the chat. How many have joined? Okay, put it in the chat. Confirm? Okay. Anyone else? Okay. I'll just proceed with the topic. I'll just proceed with it. So I'll just take the next slide. Okay. Now this is important, and this is very important. I'll just explain you everything. But first what I'll do is I'll just show you the types. Okay. I'm showing you two things. I am also telling you about types, and I'm also telling you about the construction. Okay. Now just let me move my screen so that all the things are properly visible. Okay. Now there are two types. One is called as linear potentiometer. Another is rotary potentiometer. I have just taken the diagram from the book that I made the notes because I was not getting the proper diagram to explain this thing. Line diagram was not possible for me to find. So I have taken the diagram. More than this diagram, I'll explain you everything in the OneNote system also. Okay, so there are basically two types. One is linear pot and another is rotary pot. Now, in linear pot, there is something which is called as viper. Okay, what is the viper? Viper moves across the resistive wire. Suppose this is my resistive, this is my mandrel. Mandrel is something on which I am mounting my wire, and suppose this is my wire. Okay, now the wire is supported by a wire. Is this viper moves on the wire? Okay, you can see, suppose this is my viper. Rather than viper, you can even tell this viper as jockey. Okay, in electronics term, you can call it as jockey also. So what does happen with the jockey? The jockey or viper moves along this wire. Okay, so the movement of this wire, or the movement of the viper or jockey is linear. It moves along this wire linearly. Okay, it moves along this wire linearly. The viper moves along this wire linearly. That is why what we are saying is the motion of viper is translatory. Okay, next, since it is moving in a translation motion, in a linear motion, the shape of this wire system will also be linear. Okay, the wire that will be there, it will be linearly placed. Okay, you can see here, I have just shown you there are some curls of wire. Okay, But these wires are actually, when I'll show you the diagram, you'll get to understand this thing, but these are placed linearly. These are placed like this. I'll just show you the diagram once we are done with this. Okay. It measures linear displacement. What does it measure? Suppose the wire moves from this, wiper moves from this end to this end. So suppose it covers 10 centimeter. So it measures 10 centimeter linearly. So this measures linear displacement, the maximum stroke length to minimum stroke length. If you go from minimum, the stroke that it can have is, it can have a 0.5 mm stroke to 2 mm stroke maximum. Okay. So you can see, you can easily see that this is not used for heavy measurement, heavy displacement. It is only used for lighter displacement, which is from 0.5 mm to 2 mm. Okay. Now, this is a passive transducer. Why do we call it as a passive transducer? Because it uses external battery. It uses external battery source. So once it uses external battery source, it is called as passive transducer. Okay, when we go to the rotary pot mein what will happen? You can see the rotary pot here. You can see the rotary pot. This is my rotary potentiometer. You can see some wires. Okay, I hope you are able to see the wires. So now you can see this is my wiper, this part. I have already drawn. This is my wiper. Now you can see the motion of wiper is rotational. It is rotary in shape. It measures angular displacement. Its stroke length can range from 10 degree to 357 degree. Because if it goes to 360 degree, if it goes to 360 degree, the displacement will be zero. We are measuring the displacement. We are not measuring the distance. And I hope everyone knows what is the difference between displacement and distance. So we are measuring displacement. So it can measure, or it can go up to 357 degree. It cannot go up to 360 degree. And it is also a passive transducer. Matlab, it also requires external power source or external battery. Okay. Okay. There is one more type. I'll just explain you. One is linear pot. I'll just rub all this thing. One is linear pot. Okay. Another that I've told you is rotational. Okay, rotary pot, and another which is called as helipod. If you have seen the screw, if all of you have seen the screw, you know the screw is threaded. Yes. So when it is threaded, it rotates. When you have seen a simple nail, if you have seen a nail, it rotates. Okay, it rotates, and also it translates along the motion. You know, this is translation, and this will be rotation, right? So when there are two motions together for a potentiometer, those kinds of potentiometer are called as helipods. So pods having combination of two motions, linear as well as rotational, and it is also having a resistive element in the form of helix. Matlab, this dot I have drawn, this wire will be in the form of helix. Okay, if it is in the form of helix, and if it is covering translation as well as rotational motion, then this kinds of pod are called as helipods. Okay, and it can measure up to 3600 degrees Celsius. So now, degree. Okay, so when you consider 3600, you can see, sorry, not Celsius, so sorry. When there are 3600 degree, that means it can have at least 10 turns, because you know 1 turn will have how much degree? 360 degree. So when there are 10 turns or 11 turns, 10 to 11 turns you will have. Okay, basically you will have 10 to 11 turns in helipods. Okay, when there are 10 to 11 turns in helipods, it can measure up to 3600 degree. Okay. Okay. Now what I'll do is I'll just change this thing, and I'll just go to explain you the linear pod. Can I go? Okay. How can I move from here? End show. Yeah. Now we'll just see this diagram. I've already drawn this diagram. I'll just explain you. Okay. This is the thing that I wanted to explain. This is my potentiometer topic. Okay, and we are studying linear pod. What we are studying? Linear pod. Okay. Now, what I have done here is, you can see here what I have done. This this part is called as mandrel. What is the function of mandrel? It mounts what? It mounts my wire, resistive wire. Okay, you can even call it as a shaft. That is not an issue. So it mounts my resistive wire. Okay, function of mandrel is to mount the resistive wire. Now what you can see here, this red part, I hope everyone is able to see this red. This is my wire, resistive wire. Now when we go to resistive wire, I have just shown you the resistive wire. If you go follow this arrow, you can see what I've drawn here is, this is my, just let me share the, yeah. This is the setup of my resistive wire. Matlab, if you want to see this, this will be my mandrel, okay? And you can see this is my wire. Can you see these wires? So this is nothing but my wires. Now you can see the wire length can be up to 100 centimeter. Now if we keep the 100 centimeter in an open form, the length of the potentiometer will become very large. Its length will increase. To make it compact, what do? We try to make it compact. What do? We try to fold this wire in this series. Suppose I am telling the length is 60 centimeter. So this will be 10 centimeter. Again, this will be 10 centimeter. This will be 10 centimeter. This will also be 10 centimeter. And this will also be 10 centimeter. Similarly, the last one will also be 1, 2, 3, 4, 5, 6. So I think 1, 2, 3, 4, 5. I think I have drawn twice. I have written 10. You can rub it. So this will also be 10 centimeter. So total, you can see there are 6 turns in a linear pot, right? We all can see there are 6 turns. Now, why do we need 6 turns? We know the stroke length is how much? 0.5 mm to 2 mm for our purpose. For measuring the displacement, we know the stroke length is 0.5 mm to 2 mm. So basically, even in 10 centimeter, even in 1/10 centimeter, we can cover the range. We can cover our range, the stroke length, whatever might be the displacement. Okay, so we can easily cover the range even in one set. So why do we do this is when, see, what I have done, I'll just uh, just give me a second. Can I delete? Yeah. Now what I'll do is, now look at this thing. What I've drawn in the diagram. I'll just take another color. See, can you see this part? This part, this is my wiper. Okay, now what happens here is, wiper will be not only be placed at one point. Just get it right. This wiper is at some point. Suppose this wiper, the wiper is touching the wire. I have shown it in the other way. The wiper will touch the wire. Okay, so what happens, suppose the wire is touching here, so wire will not be touching at only, the wiper will not be touching the wire only at one point. It will touch at all the points. Okay, what is the basic function? What is the basic function? We won't get the voltage or we won't get the displacement only by one means. We will get average displacement. I hope you're getting. What do we get? Average displacement. And we know that the average displacement will be more precise and accurate, right? It will be more precise and accurate. So to have the reading more accurately and precisely, the wiper will not be only one wiper. It will be a collection of wiper. One wiper will be placed here. 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 So basically what we are having is, there will be 6 sets. Matlab the wiper will move linearly, okay, along the wire. And it will move along the 6 wires that I have placed. It depends upon how much accurate I want the reading. Okay, so what we see from this diagram, from the front view, what do we see? We only see one wiper, but there not be one wiper. There will be blades of wiper, you can say. There will be blades of wiper, which you can see. I'll show you in the one of the diagrams that I have taken. I'll show you afterwards. First, what we will do is, we will try to cover all this thing. Okay. Yeah. Now, what happens here is, you can see there is a shaft. Okay, this is my shaft. Now, what you have already seen, you have seen a mandrel, you have seen a wire, you have seen a wiper, right? And you know how the wipers are connected along the mandrel, and wiper may have more than one blades. Okay. And now what happens is, it will have more than one blade. Now what happens, I'll explain you here. What happens here is, now you can see there is some screw. You can see this is my screw. Why do we put screw? Suppose I want to put a battery. You can see there is a battery. Okay, so what I want to do, if I want to put the battery, what I'll do, I'll put the battery along this terminal. So I'll use this screw to make this terminals. So the positive terminal of the battery will be connected to one side, and the negative terminal of the battery will be connected to one side. So I have connected the battery. I have kept the mandrel. I have kept the wire, and I have even kept the wiper. And the wiper, you can see this is wiper. You can see this is more of kind of a jockey also. Okay. This is also a kind of jockey. Now you can see here, this is my shaft, and the shaft is connected to something which is a system. This is my system, and this system's displacement I want to measure. Now when the system, suppose this system, I would just give me a second. Yeah. Suppose if you look at this system, suppose this is moving only in X direction. This is moving to and fro in this direction. So when it moves to and fro in this direction, the shaft is not rotating. This is more like a linear shaft. This will rotate in a linear sense. So when it will rotate, this will also rotate. When this will rotate, my wiper will move from one position. Suppose it was initially at this point, okay, and after some time it has covered this much distance, okay. So this distance, whatever distance it will cover, this will lead to change in voltage. How it will lead to change in voltage, we will see in the next slides. Okay, so I hope you understood the construction of potentiometer. Has everyone understood the construction of potentiometer? Just put it in the chat for me to proceed. Have you understood the construction of a potentiometer? How does a potentiometer look like? How do we connect the potentiometer? Where is the battery? Where is the system? Sure, Kashif? Nice. Anyone else? Is everyone getting? I'm trying to explain you as clear as possible. This is a new topic for us, but it is very easy. We will try to combine electronics with our mechanical system. Okay? Okay. Now, what I'll do is I'll just go to this slide and I'll show you a video. I could have shown you the video at the start also, but my purpose was not to show you the video. My purpose was to feed your system with some input. Now you have got some input. Now you will be able to react to the output that you are going to see on the screen. Just look at this video and try to understand the things. Just give me a second. I'll just put myself at the top. Okay. One second. I'll not be speaking in between. So I want you to listen to it very carefully. Whatever I have told you, you'll be able to see here. One second. Has everyone understood this diagram? Have you understood? Just put it in the chat for me to be confident enough to proceed. Have you understood this diagram? Have you seen the video? Just put it in the chat. Nice. Now, there was one thing that was missing from my end. I'll cover it here. Just look at this diagram. There are two types. I think someone is there in the chat. Okay, thank you. Just look at this diagram. I'll just use one more. Actually, I can't edit here. I should have taken 2 copies of this diagram, but still, just look at this thing. This is my battery voltage. Okay, this is my battery voltage, which will be my input voltage, right? This is my input voltage. And what happens when my shaft, when my wiper, you can see this wiper, when my wiper is at this position, okay, when my wiper is that at this position, you know what, just look at this thing, what I'm trying to explain. Just look at this thing. Suppose this is my wire, okay, and this is connected. The diagram might not be that proper, but still I have to draw this thing. Mashallah, this has got proper. Okay, now what I'm trying to explain, this is my positive terminal. I am connecting positive terminal to this side. This is my negative terminal. I am connecting negative terminal to this side. So what I'm trying to indicate to you, there is a flow of current. The current flows from positive terminal to negative terminal, correct? So what I am telling you is the current flows from this side to this side. Okay. Now we know that I is equal to V is equal to IR, correct? So I will be equal to V by R. Suppose, I hope you're getting I is equal to V by R. So what we are getting from here is, suppose I is equal to V. If I try to find the current for this system, I'm trying to find the current for this system. This is EI. Okay. So what I'll get is EI. Okay. What I'm trying to explain, just try to understand. I am trying to find the current for the system. So EI divided by R, this wire will have some resistance R, right? So I will be equal to, so sorry, I will be equal to, what I have got here is I will be equal to EI by R, correct? Now, what happens is, why do we call this potentiometer to be a voltage divider? This is very important. Now, we are connecting this wire, one second. We are connecting this wire. One side is connected, one side of this wire is connected to positive terminal and one side is connected to negative terminal. What happens in voltage division is, when we try to understand voltage division concept, in voltage division, if we want to measure the, just one second, I need to use some another color. Just give me a second. I'll just use this one. This will be better. When what happens in voltage division is, in voltage division, the voltage gets divided. Now, if I want to measure the current, suppose I want to measure the voltage across this thing, this wire. If I want to measure, I know the current across the system. The current across the system is EI by R. But if I want to measure the voltage across this terminal, I hope you're getting. What should be the voltage across this terminal? The voltage across this terminal should be the equal to the voltage that I am supplying. Suppose I am supplying 10 voltage, 10 volt. Sorry, I am supplying 10 volts. So if I am supplying 10 volts, what will happen? This wire should get 10 volt. Now, how will it get 10 volt? Here it is positive and here it is negative. Potential difference. If you have heard about potential difference, positive is at a higher potential and negative is at a lower potential. So when we are at this point, the voltage will be 10 volt. And when we move from this point to this point, the voltage will decrease to 0 volt. I hope you're getting. The voltage across this wire will get decreased. It will move, it will be maximum at this point. It will be 10 volt here. And since we keep on moving from this point to this point, when we move from this point to this point, the voltage will get divided. Okay. This will get divided across the length. I hope you're getting. If it is 10 volt at this point, this should become 0 volt at this point. And again, we will get, the current will flow from here to here. Okay. I hope you're getting what I'm trying to explain. So this is the basic concept of voltage division. So what can you understand from this thing? One important thing, I'll just show you. I think, is there someone in the chat? No. So what I wanted to show you is, just look at this thing. If you look at this diagram, see, this is my 1 point. Okay, this is my positive point and this will be my final point, because my wiper is at this position right now. So what I'll do is I'll measure, see, I will measure, just look at this point. I have connected 1 point here. You can see this point is connected here and this point is connected here. Okay. And what I'm doing is, suppose I have kept a multimeter here. I have kept a multimeter here. So when I've kept a multimeter, I'll be able to measure the voltage across these 2 points. I hope you're getting. Now, if the voltage here is 10 volt, I hope you're getting. And suppose the voltage here is 6 volt. Okay, so 10 minus 6, what will be the voltage difference? It will be 4 volt. I hope you're getting. I hope you're getting. Suppose the voltage here is 10 volt. The input voltage, what I'm trying to tell you is, the input voltage is how much? 10 volt. So this will be at the positive terminal, and wherever is my wiper, wherever will be my wiper will become my negative terminal. Suppose the wiper is at 6 volt. Suppose that point is 6 volt. So if that point is 6 volt, then 10 minus 6 will be what? That will be my potential difference. So the potential difference that I'll get across this circuit will be what? This will be 6 volt. So that is what we try to measure here. I hope you're getting. This is what we try to measure. We try to measure the potential difference, okay, across the length of the wire, which is into consideration when the wiper moves from plus point to another point. When the wiper moves to this point, when the wiper moves to this point, now what do we see? this will again have this wiper position. Okay, this wiper position, suppose this it has covered the total distance, so it has already taken the value of 10 volt. So the difference will be 10 volt minus 10 volt, which will be equal to what? 0 volt. Okay, I'll just use the same color. Okay, what we have got is R naught is equal to Rp into Xi divided by Xt. Now, what is Xt? Xt is the length of the whole wire. Suppose this is my wire. So this length is called as Xt. Okay. Now, suppose the wiper is at this position, my wiper. Okay, if my wiper is at this position, so this length from the positive terminal, see, if this is positive terminal, then this will be negative terminal. This part will be connected to the positive terminal of the battery, whatever is my battery. Okay, and this part will be connected to negative terminal of the battery. We all know that that the battery has two terminals. Okay, positive and negative. So what we will do is we will connect one part of the battery to the positive terminal. This, suppose this is my positive terminal, this is negative, so this will act as positive and this will act as negative. Now since this is this part, this situation, this thing is connected to the positive, we will measure wherever is the wiper, that point will be negative, because we are going from positive potential difference to negative potential difference. Like we are going from higher potential difference, okay, we will go to lower potential difference. So since this is at a positive level, so we will move from here, we will measure whatever we are going to measure with respect to wiper, we will measure from here and we will go where the wiper is ending its position. So the place where wiper is ending its position is this. So this will be our next negative terminal. So this will be, this is my input voltage EI, and this will be my output voltage E naught. I hope everyone is understanding. Okay, so this output voltage, I'll measure output voltage across this. What I'll do, I'll use some connections. I'll use to measure this output voltage. What I'll do is I'll just use another color to make the things more clear, or I can do one more thing. I'll just draw it again. Just for your simplicity, I'll draw it in a more proper way. So this is my wire. Okay, this is my wiper. Okay, to this place, this to this, wherever I'm going to measure this length is called as initial moment of the wiper, which is Xi, and across these two terminals, okay, where this terminal is positive, this terminal is negative, I'll be measuring a voltage which is called as E naught, output voltage. Okay, and what I'm saying, another thing, this terminals will be connected to a battery. Okay, these two terminals will be connected to a battery. Since this is positive, this is negative, so this is considered to be a positive terminal. This is connected to the positive end of the battery. You can see this is connected to positive end, and this will be connected to the negative end of the battery. Okay, you can see this is my negative end. Okay, this one. Okay, so what I am doing, I am connecting the battery terminal to one terminal to positive, one terminal to negative. So this will be at a higher potential difference, and this will be at a lower potential difference. Okay, this is the thing that I have explained: higher potential difference and lower potential difference. And we will measure the wiper, whatever the distance that wiper is covering. Okay, this distance will be measured. Since this wiper is also made up of a metal, okay, we will know which material it is afterwards when we go to the slide. But this is also a material, so this will also conduct electricity. So what we will do, this wiper, or you can even say jockey, this will be my one end, which will be at a negative terminal, and this point will be considered as my positive terminal. Okay, so I'll be measuring this value, and this length, total length of the potentiometer wire will be considered as XL. Okay, so we know all this thing now. So what do we need to do? We just need to write something which is R naught is equal to Rp into Xi by Xt. We derived this thing. Okay, we derived it in the last lecture. Okay, now we know that what is Rp? Rp is the potentiometer resistance. I'm just making it revision for everyone. Those who are not there also, they can also benefit from it. Potentiometer resistance is Rp. R naught will be the output resistance. I hope you're getting. Whatever is the output resistance, this will be my output terminal resistance. Simple. Or wiper resistance. Due to the moment of wiper, whatever resistance I am getting, that will be my RO, which is output terminal resistance. Okay. Now I know what is Xi. I have already stated Xi is initial moment of the wiper. Xt is the total length of the wire. And Xi is initial moment of the wiper on what? Initial moment of the wiper on, one second. Initial moment of the wiper on that wire, potentiometer wire. Now, according to Ohm's law, what is the Ohm's law? What do we get from Ohm's law? We understand by Ohm's law that V is proportional to I, right? And we also know that V will be equal to IR. And since current is constant, we will keep the current constant in this circuit. So what we are assuming that voltage will be proportional to resistance. Okay. Now in our topic, what do we consider voltage to be? We consider voltage to be EMF. EMF will be proportional to the resistance. Okay. So EMF at the output terminal, let it be considered as E naught. So this is the voltage or EMF at output terminal. Okay. Or voltage due to moment of wiper. Whatever you want to write, you can write. It is all upon your understanding. Voltage due to moment of wiper. I am writing it big so that you people can see it properly. EI will be the input voltage. I hope you're getting input voltage, or you can even say battery voltage, whatever you want to write. Okay, voltage, not voltage. Okay, so you write it properly. Next thing, I'll share the notes also, don't worry about it. Next, what I'm saying is, now since I know all the terms, now what I'm telling is E naught will be proportional to R naught, right? And EI will be proportional to, can anyone let me know? I'm just unmuting. I'm allowing you to unmute. E naught will be proportional to R naught. Then EI will be proportional to anyone? R,
RP,
I,
R,
P,
I,
RP,
RI तो है ही नहीं ना बेटा. What we are considering is R.
RP,
RT,
Okay.
P.
Resistance of the potentiometer. Very nice. Now, what we will do next is we will divide both the system. So what I'm going to do now is I'm just going to divide both the terms. Just look at this. This is the place where I did an error and you people were not able to identify. E naught by EI will be equal to R naught by RP. Now you can even do either way. Whatever you want to do. So E naught, R naught will be equal to, R naught is RP into XI by, I think XI by XT, correct? Divided by क्या रहेगा? This will be divided again by RP. Okay. Okay. So since if we try to simplify this thing, what will happen here is this will get cancelled with this RP. What will remain is E naught by EI is equal to XI by XT, right? What we are getting here is E naught by EI is equal to XI by XT. Now just look at this thing. Now just look at this thing. What I'm saying to you is E naught by EI is equal to XI by XT. Now see, E naught क्या था? E naught आउटपुट वोल्टेज था या नहीं? आउटपुट था ना? आया ना? ठीक है. EI क्या था मेरा? इनपुट था या नहीं? और ये क्या है मेरा? इनिशियल है या नहीं? करेक्ट. और ये क्या है मेरा? टोटल लेंथ है या नहीं? तो अगर मुझे सेंसिटिविटी लिखनी है, क्या लिखनी है? सेंसिटिविटी ऑफ अ इंस्ट्रूमेंट अगर मुझे लिखना है तो सेंसिटिविटी इज नथिंग बट रेशियो ऑफ मैग्नीट्यूड ऑफ रिस्पॉन्स. दिस इज नथिंग बट मैग्नीट्यूड ऑफ रिस्पॉन्स अपॉन व्हाट डू वी से? इनपुट सिग्नल. जस्ट थिंक इट करेक्टली. Just look at this thing correctly. Now magnitude of response. Out of all this thing, what is the magnitude of response that you are going to observe? This is the magnitude of response that you are going to observe. In your potentiometer, when you connect this thing, you are going to, magnitude of response will be this E naught. E naught will be measured across the wiper. I hope you remember the wiper and the positive terminal of your potentiometer wire. So this is considered to be my E naught. Okay, output voltage. So magnitude of response that you are actually going to measure is what? It is going to be magnitude of response. It will be E naught. And what will be my input signal? If you consider all this term, what is the input signal? The movement of the wiper. The wiper is moving from this position. Suppose this position to it is moving to this position, right? So this is the motion of the wiper, which will be my input signal Xi. So what is my input signal? Input signal is Xi, right? So I have got the sensitivity. Sensitivity is nothing but output upon input. So output is voltage that I'll measure across the wiper and the positive side of the potentiometer. Xi will be the moment of the wiper. from positive to the negative side where it is moving, right? So this will be my sensitivity. Okay, is it okay? Okay, now just look at this thing again. What was our term? E naught by ei. What did we got? Xi by xt. So if I try to simplify this or rearrange this, E naught by Xi, I can write it, will be equal to what? Ei by xt, right? Right now? Okay. So if E naught by Xi is equal to, what I'm saying, E naught by Xi is equal to Ei by xt. So now remember the K formula. K was what? E naught by Xi. So E naught by Xi can also be written in terms of Ei by xt. Is it clear for everyone? I'm unmuting you. Have you understood?
Yes, sir.
Yes, sir.
What is
Yes,
the
sir.
voltage you are getting? EI क्या है? EI, what is EI? Input voltage है या नहीं?
हाँ सर.
Yes, sir.
Very nice. तो ध्यान देना, E नॉट बाई XI का जो रेशियो है, अगर इंस्ट्रूमेंट को सेंसिटिव होना है, क्या होना है? सेंसिटिव होना है, तो E नॉट बाई XI का रेशियो किसके इक्वल होना चाहिए? EI बाय XT.
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 अगर ये रेशियो, मैं बोल रहा हूं कि अगर ये रेशियो नॉन लीनियर रहा तो मेरा इंस्ट्रूमेंट क्या हो जाएगा? नॉन लीनियर इन नेचर. बराबर? अगर ये रेशियो बार बार सेम नहीं आ रहा है, जैसे कि देखो सिंपल सी चीज क्या है, EI क्या है? कांस्टेंट है. XT क्या है? कांस्टेंट है. तो ये वैल्यू कांस्टेंट है या नहीं फॉर द इंस्ट्रूमेंट? तो अगर ये वैल्यू फॉर द इंस्ट्रूमेंट हमेशा कांस्टेंट है बेटा, दिस इज ऑलवेज कांस्टेंट एंड दिस विल वेरी, राइट? दिस विल वेरी. बट इंपॉर्टेंट चीज क्या है, जब भी मैं इसका ग्राफ बनाऊंगा, क्या बनाऊंगा? इसका ग्राफ बनाऊंगा. और अगर मेरा इंस्ट्रूमेंट लीनियर है, कैसा है नेचर में? लीनियर है, तो इसकी स्लोप क्या रहनी चाहिए बेटा? इसकी स्लोप क्या रहनी चाहिए? इक्वल. क्या रहनी चाहिए? इक्वल. तो अगर मैं इसको ड्रॉ करना चाहूँ, कहीं पे भी ले लेता हूँ. सपोज करो ई नॉट को मैं वाई एक्सिस पे ले लेता हूँ और एक्स को मैं कहाँ ले लेता हूँ? एक्स एक्सिस पे ले लेता हूँ. तो ई नॉट बाय एक्स अगर लीनियर रहेगा तो मेरा इंस्ट्रूमेंट कैसा रहेगा? लीनियर इन नेचर रहेगा. ठीक है, क्योंकि ये तो हमेशा क्या रहेगा? ये तो हमेशा इक्वल रहेगा. बराबर? दिस विल बी इक्वल टू दिस. तो अगर मेरे इंस्ट्रूमेंट को सेंसिटिव रखना है, साथ में लीनियर रखना है, तो इंपॉर्टेंट क्या है? ये जो रेशियो है EI बाय XT का रेशियो है, जो कि हमेशा क्या रहेगा? कांस्टेंट रहेगा. वो किसके इक्वल रहना चाहिए इंस्ट्रूमेंट के अंदर? E नॉट बाय XI. उसको हमेशा मैच करना चाहिए. लीनियरिटी में वो हमेशा मैच करना चाहिए. ओके ओके, is it
Yes,
okay?
sir.
Yes, sir.
Okay. Now we will go to some things which is called as characteristics. Now I'll just share the second slide. I'll just share the slide with you. Just let me share the slide. Where were we? I think we were here. We have seen this? No. We have just seen this. We'll just go to this side. Just look at this. Okay. Now, what we have completed till now from this slide is we have completed the purpose. We know the construction and types. There are 2 types to 3 types. Then we also know the working principle. Now we are going to one very important thing that is called as characteristics. I'll just show you the characteristics. What are the various characteristics for which you buy a potentiometer? Then what is the characteristics that you need so that you can buy a potentiometer? Potentiometer is very cheap in the market. It is available at a very cheap rate. I'll just take one good, okay, which color? This color, I think it will be visible, but this is of a large size. I'll just change it. One second. This will also do. Now, just look at this thing, what I'm telling. Characteristics. Of potentiometer. I'll just share 2 main characteristics. Okay. First 3 characteristics actually I'll share. First one is, together I'll share 2 characteristics: linearity and sensitivity. Okay. Now, if I'm going to share linearity and sensitivity, I'll be asking you some question. I'll first share some data for you. For instrument to be linear, there is something which is very much required. अगर एक इंस्ट्रूमेंट में आउटपुट रिस्पॉन्स और इनपुट रिस्पॉन्स लीनियर रखना है तो उसका रेजिस्टेंस लो होना चाहिए. याद रखना, उसका रेजिस्टेंस क्या होना चाहिए? लो होना चाहिए. रेजिस्टेंस जितना लो रहेगा उतना अच्छा लीनियर इंस्ट्रूमेंट रहेगा. रेजिस्टेंस जितना हाई रहेगा उतना ज्यादा नॉन लीनियर इंस्ट्रूमेंट रहेगा, क्योंकि रेजिस्टेंस क्या करता है? फ्लो ऑफ करंट को रोकता है. इट रेजिस्ट द फ्लो ऑफ करंट. रेजिस्टेंस का यही काम है. इट डज नॉट अलाउ द करंट टू पास थ्रू द वायर. तो रेजिस्टेंस जितना कम रहेगा इंस्ट्रूमेंट उतना ज्यादा क्या रहेगा? लीनियर रहेगा. ओके. So first thing that I'm sharing with you is very important thing. If the resistance is low, right? If the resistance is low, linearity will be high. Linearity will be high, matlab the instrument will be very good in linearity. Okay. Now just look at this thing, sensitivity. What did we define sensitivity as? Sensitivity was defined as E naught by Xi, right? Right now, and it was equal to EI by XT. Correct? It will be equal to EI by XT. I hope you're getting right. Right or not?
Yes, sir.
Now important thing. Now just look at this thing, what I'm saying to you. Now I'll just share one term with you, which is called as power. Power in terms of resistance, and suppose in terms of resistance and voltage is P is equal to V square by R. We all know this thing. If we want to write power, one second. If I want to write power, how can I write power? One second. Power is nothing but P is equal to V square by R. Okay, now suppose this is my RP, okay, and this will be my EI, because this is power is defined for the instrument, and for an instrument, if I want to define power, I will define it in terms of the constant of the instrument. So the constants of the instrument are the input voltage of the battery, which will provide the power, and the resistance of the wire, which will try to resist the power. Okay, so if I want to write power, I can write it as EI square by R. Okay, so what I am telling you is, I am telling you one very important consideration. What is P? P is nothing but EI square by R. So what do you get from this RP? What you are getting, EI square is proportional to RP, right? So what we can deduct from here is E is proportional to root of RP. Matlab, very important thing. Just look at this thing. What I have written, EI is proportional to root of RP. Matlab, whenever RP increases, EI will also increase, right? And whenever RP decreases, EI will also decrease. Is it clear for everyone?
Yes, sir.
When RP increases, input voltage will increase. When RP decreases, with respect to power, input voltage will decrease. Correct? Now, sensitivity क्या था? Sensitivity was E naught by Xi, which can also be written as EI by XT. अब ध्यान दो, ठीक है, बहुत इंपॉर्टेंट चीज है, ध्यान दो यहाँ पर अच्छे से. अभी इंपॉर्टेंट चीज क्या है? सपोज करो मैंने क्या किया, आरपी को डिक्रीज किया. आरपी को मैंने क्या किया? डिक्रीज. मुझे बताओ, आरपी डिक्रीज होगा तो लीनियरिटी क्या होगी? अगर आरपी डिक्रीज,
इंक्रीज होगी.
वेरी नाइस. लीनियरिटी क्या होगी?
इंक्रीज होंगी
इंक्रीज
लिनियरिटी.
होगी सर, इंक्रीज.
इंक्रीज होगी ना. बट जब आरपी में डिक्रीज कर रहा हूं, आरपी में क्या कर रहा हूं? डिक्रीज कर रहा हूं ना, डिक्रीज. तो इनपुट वोल्टेज क्या हो रहा है? इनपुट वोल्टेज क्या हो रहा है?
डिक्रीज हो रहा है.
डिक्रीज हो रहा है.
डिक्रीज.
जब मेरा इनपुट वोल्टेज डिक्रीज होगा तो सेंसिटिविटी क्या होगी? क्या होगी?
डिक्रीज होगी.
डिक्रीज. सेंसिटिविटी भी डिक्रीज हो जाएगी.
तो बात है, इसका मतलब ये है, इसका मतलब इंपॉर्टेंट ये है, एकदम सिंपल सा, कि जब मैं बेटा आरपी को डिक्रीज करता हूँ, मतलब पोटेंशियोमीटर का रेजिस्टेंस में कम करने की कोशिश करता हूँ, तो मैं लीनियरिटी तो बढ़ा लेता हूँ, मतलब मेरा इंस्ट्रूमेंट हाईली लीनियर हो जाता है. बट उसी के साथ जब मेरा आरपी क्या होता है? डिक्रीज होता है. तो ठीक है, विथ रिस्पेक्ट टू पावर रेटिंग इज नथिंग बट EI स्क्वायर बाय RP. हु इज दिस पर्सन? प्लीज म्यूट योरसेल्फ. म्यूट योरसेल्फ. With respect to power rating, which is nothing but one of the important characteristics of the instrument, इससे मुझे क्या पता चल रहा है कि जब मेरा RP डिक्रीज होगा तो EI भी मेरा क्या होगा? डिक्रीज होगा. और EI अगर मेरा डिक्रीज होगा तो विथ रिस्पेक्ट टू EI बाय XT मेरा सेंसिटिविटी भी क्या होगा? डिक्रीज होगा. ओके, तो एक चीज क्या समझ में आई कि एक इंस्ट्रूमेंट में वी कैन, इन अ सिंगल इंस्ट्रूमेंट, आई विल जस्ट राइट इट, इन अ सिंगल पोटेंशियोमीटर, ओके, in a single potentiometer, you have to compromise between the two characteristics. You have to compromise between, can you say linearity or sensitivity based on your requirement. Okay, based on your requirement. Now I will just ask you a question. Anyone can respond. I want other people to respond. सेंसिटिविटी को कब कॉम्प्रोमाइज करना चाहिए, कब कॉम्प्रोमाइज नहीं करना चाहिए, या कब करना चाहिए? लीनियरिटी तो नहीं कर सकते हम, पर सेंसिटिविटी को कब कॉम्प्रोमाइज करना चाहिए या नहीं करना चाहिए, बता सकते हो? एनीवन? When should we compromise on sensitivity of the instrument? Anyone? Anyone? Sufyan? Ya Naushad? Anyone? When should we compromise on the sensitivity of the instrument? When can we compromise? Yes? Anyone? When can we compromise on the sense? Okay, I have not allowed you to. In mass production. Okay. Anything else? I'm allowing you to unmute. Anyone? When can we compromise on the sensitivity of the instrument? Anyone? I have allowed you to unmute. कॉम्प्रोमाइज कब कर सकते हैं सेंसिटिविटी की, इंस्ट्रूमेंट की सेंसिटिविटी कब कॉम्प्रोमाइज कर सकते हैं हम? यस, कैन आई गेट सम आंसर? ओके, आई विल जस्ट रिस्पॉन्ड. थैंक यू. आई वाज नॉट एक्सपेक्टिंग दिस. सेंसिटिविटी को कॉम्प्रोमाइज तभी कर सकते हैं जब आउटपुट सिग्नल, सेंसिटिविटी कॉम्प्रोमाइज तभी हो सकती है जब आउटपुट सिग्नल मेजरेबल है और डिटेक्टेबल है. मतलब अगर आउटपुट सिग्नल स्मॉल है तो सेंसिटिविटी हाई चाहिए, सेंसिटिविटी हाई चाहिए. बट आउटपुट सिग्नल लार्ज है एंड मेजरेबल है, इजीली मेजरेबल है, इजीली मेजरेबल है, तो वी कैन कॉम्प्रोमाइज ऑन सेंसिटिविटी. वी डोंट वांट द इंस्ट्रूमेंट टू बी मोर सेंसिटिव, क्योंकि मोर सेंसिटिव होगा तो भी प्रॉब्लम होगा. इनपुट टू आउटपुट रेशियो कांस्टेंट रहना चाहिए. तो सेंसिटिविटी को कब कॉम्प्रोमाइज कर सकते हैं? जब अगर हमारा सिग्नल बहुत लार्ज रहेगा और इजीली मेजर कर सकते हैं तो वी कैन कॉम्प्रोमाइज ऑन सेंसिटिविटी. रादर देन एक्सेप्ट फॉर दिस पॉइंट वी शुड नेवर कॉम्प्रोमाइज ऑन सेंसिटिविटी. मतलब if the signal is small we should never compromise on sensitivity. We can compromise somewhat on linearity of the instrument, but we cannot compromise on sensitivity. I hope that answers your question, that the question that you have not even asked. Okay, now I'll just take some questions. I'll just share this thing with you. We are just about to end. I'll just share the material. What are the various materials? I'll just share it with you. Now, what are the material? First is potentiometer wire, which is also called as resistive wire. It is made up of constantin or eureka or manganese. I'll just shift my window screen to this place. Now, it is made up of constantin. This is a material constantin, or it is also made up of manganese. Why do we use this material? Why don't we use steel? I'll just inform you, due to low temperature variation. This is very important. देखो, टेम्परेचर वेरिएशन अगर ज्यादा रहेगा, टेम्परेचर से सेंसिटिव रहेगा, अगर टेम्परेचर सेंसिटिव रहेगा मेरा इंस्ट्रूमेंट, तो ऑटोमेटिकली इसका रेजिस्टेंस बढ़ जाएगा, क्योंकि R इज इक्वल टू R0 इंटू 1 प्लस अल्फा टी. आई होप यू रिमेंबर, R इज इक्वल टू R0 इंटू 1 प्लस अल्फा टी. तो वी ऑलरेडी नो R इज प्रोपोर्शनल टू T. तो अगर टेम्परेचर सेंसिटिव रहेगा और हाई टेम्परेचर वेरिएशन रहेगा, मतलब अगर ये हीट रेजिस्टेंट ज्यादा नहीं रहेगा, एक होता है हीट रेजिस्ट कर लेना, एक होता है हीट के वजह से हीट हो जाना. तो अगर इसका टेम्परेचर लो रहता है, ठीक है, अगर टेम्परेचर इसका हाई रहता है तो रेजिस्टेंस हाई हो जाएगा, और रेजिस्टेंस हाई हो जाएगा तो जो मेरा वायर है ना, जो इसका आरपी है, रेजिस्टेंस ऑफ पोटेंशियोमीटर है, वो वेरी होगा. और वो वेरिएशन अगर होगा तो जो मुझे रीडिंग मिलने वाली है वो मुझे करेक्ट नहीं मिलने वाली है, क्योंकि दिस इज बेस्ड ऑन ओम्स लॉ. दिस मटेरियल, दिस पोटेंशियोमीटर वायर इज ओनली गोइंग टू गिव मी द डिस्प्लेसमेंट. This potentiometer wire will give me the displacement in terms of what? In terms of some kind of a voltage. I hope you see this thing. We have already derived that thing. What was that thing? S is equal to, or you can directly write E naught by Xi is equal to EI by XT. So we know this value can only be derived, this value can only be derived if we are able to find EI properly. So if I am able to find E naught, EI, XT properly, then only I'll be able to find XI properly. So this value actually depends on EI, and EI depends upon RP. I hope you're getting. It depends, EI and E naught depends upon resistance of the wire. So it is very important that you use the wire which is having low temperature variation. And two wires which are having low temperature variation. First one is constantin, which is used in potentiometer. Second is manganese. Okay, I've already written the chemical formula. It is having copper 55%, nickel 45% alloy. Okay, this is copper, manganese, and nickel alloy. Okay, now mandrel on which we keep the wire, that is made up of ceramic, on which we wound the wire. Suppose this is my mandrel and I am trying to wound the wire on this. Okay, okay, and this wire is linear in nature. I hope you're getting. This wire is kept in linear in nature. I have already explained you all this thing. So this mandrel, it should be made up of ceramic so that it is also temperature insensitive. Okay, wiper and jockey, it is made up of platinum, nickel chromium, or nickel copper alloy. Again, all these materials are having low temperature variation. Why they are having low temperature variation? Matlab, they are insensitive to temperature variation, because what will happen if they are sensitive to temperature variation? If wiper and jockey is sensitive to temperature variation, I have already written, no, I have not written here. If the wiper is sensitive to temperature variation, it will lead to wear of the jockey. And if the jockey is wearing, or if the jockey is not aligning properly, misalignment हो रहा है अगर jockey का, due to temperature variation, length changing of the wiper, तो automatically क्या होगा? The reading that you will get will not be precise. Okay, so I have already explained you all the materials. Can anyone repeat it for me? What are the various materials that we are going to use? For resistive wire, what should be the material? Resistive wire, what should be the material? I have given you the authority to unmute.
Eureka or magnesium.
Constantin or manganese. And for mandrel?
Ceramic.
And for
Ceramics.
viper?
Platinum, chromium, nickel,
Like
nickel, copper,
Why
alloy.
this material based on which characteristics it should have?
Low temperature value.
Very nice. Now, just we'll go to the second part, which is all about working principle. I have already told you what do you mean by voltage division and Ohm's law. I have explained you. Now, working resistive wire is attached to the mandrel. We already know. Wiper movement is controlled by the system whose displacement is to be measured. Okay. And moment of wiper along the wire length gives the displacement value in terms of output voltage. This is already explained via the derivation. The output voltage is calibrated in terms of displacement. I have already explained. E naught by xi will be equal to ei by xt. By this we can calibrate, we can calibrate this value, okay, if we know all these terms properly. Okay, there is one more method to measure xi. Okay, there is one more method. We can even use a scale, but this scale, we can even use a scale. Okay, this scale, suppose I am using a scale and this is the wiper moment. Now this scale, whatever the scale is calibrating, we have to again calibrate in terms of the displacement. Okay, so if both the things are linear, suppose the displacement is by 1 unit and scale is scaled for 2 units of movement, so we have to automatically we have to feed this things. आई होप यू आर गेटिंग. अगर एक यूनिट का कहीं पे डिस्प्लेसमेंट हो रहा है और स्केल पे क्योंकि लार्ज एम्पलीट्यूड चाहिए, मेजरमेंट में सिंप्लीफिकेशन हो, मैं क्या कर रहा हूँ, एक यूनिट मेजरमेंट के लिए मैं 2 यूनिट का मूवमेंट करवा रहा हूँ यहाँ पर वाइपर का. ठीक है, अगर मैं इसको कंट्रोल कर रहा हूँ तो मुझे ऑटोमेटिकली क्या करना पड़ेगा, जो भी मेरा आंसर आएगा, सपोज करो 20 माइक्रॉन्स डिस्प्लेसमेंट हुआ है. ठीक है, तो 20 माइक्रॉन्स डिस्प्लेसमेंट हुआ है तो 20 माइक्रॉन बाय 2 करूंगा तो 10 माइक्रॉन मेरा क्या हो जाएगा, 10 माइक्रॉन मेरा हो जाएगा सिस्टम का डिस्प्लेसमेंट. ओके, so this way we can calibrate the output voltage in terms of displacement either by using a scale in presence of wiper. Wherever is my resistive potentiometer, I'll just use a scale. Okay, and we know the length of the potentiometer wire is around 100 centimeter. It is in total it is preferred to be 1000 centimeter, and it is divided in the steps of 10 steps it is divided of 100 centimeter each. Okay, so the output voltage can be calibrated in terms of displacement. Okay, now we'll go to the next slide. I'll just share. Can I proceed? 1 second. Yeah. What are the characteristics? We have already seen the characteristics. What are the characteristics? One of the characteristics is power rating. Another characteristics is linearity and sensitivity. What is the advantage? It is very cheap. You will even get the potentiometer of your choice at 300 rupees. Okay. One thing I forgot to explain you, power rating. The power rating is expected to be, sorry, yeah, the power is expected to be 5 watt, so it is operating at low power. ठीक है, it is having low power consumption. Low power consumption. Remember this thing. At room temperature मतलब 21 to 25 or 30 degrees Celsius, what is the power rating that is expected from this instrument? It is 5 watt at room temperature and it is having low power consumption. Okay, remember this thing. So power rating already know, 5 watt at 25, 21 to 30 degree you can say at room temperature. Then it is inexpensive. You can even buy with, since it is low power, it is having low power rating, you can even buy it at a cheaper price. It is already available. I have seen it on Amazon. It is available at 300 rupees also, and even on India Mart. It is very simple to operate. You just need a galvanometer, you need a battery, you need some wires, and you need a potentiometer, and you need to attach the wiper to the system which is of which you are going to measure the displacement. Now it measures large amplitude and very high electrical efficiency. It is very good in electrical efficiency. Okay, it is having very high electrical efficiency. Why it is having high electrical efficiency? The due to this characteristics, linearity and sensitivity. Okay, now we will go to the limitation. It requires large power force input voltage to initiate the wiper movement. Okay, input voltage is very high, power rating is low. Okay, now I'll explain you what is the relation between input voltage. See, P is equal to EI square by R. Okay, power is low. Okay, and input voltage is required to be very high. So your resistance should also be high. ठीक है, तो what I am saying, एक लिमिटेशन क्या है? एक तो पावर कंजम्पशन क्या चाहिए, इसको कम चाहिए. ठीक है, पावर कंजम्पशन अगर इसका कम रखना है तो प्रॉब्लम क्या है? अगर पावर कंजम्पशन कम रहेगा तो ठीक है, इनपुट वोल्टेज कम रहना चाहिए. बट अगर आपको सपोज करो कोई लार्ज सिस्टम है, सपोज करो एक हैवी सिस्टम है जिसका वेट बहुत ज्यादा है, सपोज करो इसका वेट है 1 टन. ठीक है, और आपको इसका बेसिक हल्का सा माइक्रोन्स में इसका डिस्प्लेसमेंट आपको सपोज करो ये यहाँ से यहाँ पे जा रहा है, सिर्फ इतना डिस्टेंस मूव कर रहा है, तो प्रॉब्लम क्या होने वाला है? इसको मूव, जब ये मूव होगा तो ये सिग्नल को वाइपर को क्या करना पड़ेगा? ये सिग्नल को वाइपर को क्या देना पड़ेगा? यहाँ तक देना पड़ेगा. तो इसके लिए इंपॉर्टेंट क्या है कि आपका जो इनपुट वोल्टेज है वो क्या होना चाहिए? बहुत ज्यादा होना चाहिए, ताकि आपका वाइपर का इनिशियल मूवमेंट जो है ना, वाइपर का मूवमेंट वो इनिशिएट हो. नेक्स्ट क्या बोल रहा है? कंटेमिनेशन ऑफ वाइपर लीड्स टू वियर, मिसअलाइनमेंट एंड नॉइज जनरेशन. हेंस लाइफ ऑफ ट्रांसड्यूसर इज लिमिटेड. एंड यू कैन डायरेक्टली से वन थिंग अबाउट ट्रांसड्यूसर कि इसकी लाइफ डायरेक्टली प्रोपोर्शनल है वाइपर की लाइफ में. ठीक है, अगर वाइपर की लाइफ अच्छी नहीं रहेगी तो आपको अल्टीमेटली क्या करना पड़ेगा? वाइपर को रिप्लेस करना पड़ेगा. तो इसकी लाइफ दो चीज पे डिपेंड करती है, एक तो वाइपर पे डिपेंड करती है, दूसरा क्या डिपेंड करती है कि आप इसका पावर रेटिंग, जो कि इसका डिजायर्ड पावर रेटिंग क्या है, 5 वॉट है. क्यों इतना कम पावर रेटिंग है? क्योंकि आप इसको बेसिकली किस लिए यूज करते हैं? स्मॉल एम्पलीट्यूड के लिए यूज करते हैं. याद रखना, जहाँ पे स्मॉल डिस्प्लेसमेंट होता है ना, वहीं पे यूज करते हैं. जहाँ पे वेरी लार्ज डिस्प्लेसमेंट रहेगा, जहाँ पे ज्यादा फोर्स लगेगी, वहां पे इसको यूज नहीं कर सकते. इसका लिमिटेशन. ओके, तो दिस इंस्ट्रूमेंट इज बेसिकली यूज्ड टू मेजर व्हिच काइंड ऑफ डिस्प्लेसमेंट? वेरी स्मॉल डिस्प्लेसमेंट. डन. ओके.